Hey YouTubers, this is Martin White explaining the differences between the Big Bang Theory and evolution. Let's start. What is the Big Bang? The Big Bang Theory is the prevailing cosmological model of the birth of the universe. The model postulates that at some moment all of space was contained in a single point from which the universe has been expanding ever since. Modern measurements place this moment at approximately 13.8 billion years ago, thus considered the age of the universe. Thank you to Wikipedia for that free information. Basically, is an attempt to explain for all the patterns we see in the universe. Following the cosmological principle, it even shows that everything in the universe is moving away from a certain point. The problem with this principle is that the center cannot be determined because at any point it can be shown in the center of the universe. I'll go over why in another video. Now, what is evolution? Evolution is a change in inherited characteristics of the biological populations over successive generations. Evolutionary processes give rise to diversity at every level of biological organization, including species, individual organisms, and molecules such as DNA and proteins. More or less, I've just thrown some big science words at you, so I just want to go through what they're saying in more of a general view. Suppose you have your parents. Naturally, your parents gave birth to you. Although you look quite like your parents, there are notable differences, some of which you received from your mother and some you're receiving from your father. Now in time you have kids, and they look somewhat like your parents but look more like you. In time those kids will have kids that look less like your parents and less like you. Over time this long chain will spawn children that look almost nothing like your parents or you for that matter, but they are your descendants. Although there are more variables to this is just a brief basic overview. Now, how do scientists show something of this nature? They use phylogenetic trees. Oof, it's my favorite word. In short, phylogenetic trees are used to track where each species has branched off from another species, forming its own lineage. Like the example I gave before, they each started at a single point, which is the black line on the graph here. And then they branched off, which you see you have different branches here, 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 and here. Forming the main domains as of now, the bacteria, the archaea, and the eukaryota. The reason I like phylogenetic trees is because they make this simple for us to see and understand. Here you have this main species which has broken off into this new species and this one as well. And then at each of these branch points you can see where it forms a new branch. This is where this species is broken off into a subspecies. So then this species here has broken off into the Acophex, into Thaumaturga, into Bacteriocytophaga, and to a whole bunch of other stuff. And then you can see more branches here and more branches here. This is basically how phylogenetic trees work, and they aren't hard to understand. It's just if you don't know what it is and you're seeing it for the first time, it does seem rather disorientating, which is why I'm making this video. So now we go over the similarities and differences between the Big Bang Theory and evolution. In short, they don't have that many similarities. This is because the difference between the Big Bang Theory and evolution is simple. Evolution attempts to explain what happens after life sprung up, and the Big Bang Theory attempts to explain how the universe was started. They are no more related than you and I. They are two pieces to a cosmic jigsaw puzzle. So then we're going to go over some common questions and misconceptions that I've been hearing. The first question is, if we come from monkeys, why are there still monkeys? For the reasons I explained before, it's evident why there are still monkeys. Because to a certain extent, we aren't saying that we come from present-day monkeys. That is the misnomer that a lot of people have. We are descendant from monkeys down the phylogenetic tree, and we branch off into our own subspecies, into homos, which a lot of people will be laughing at, but we are homo sapiens, and we branched off into these different sections of subspecies, which in time we will also be our own species and or create our own subspecies. So now we continue. We ask, why? What proof is there of this theory? Well, between apes and humans, let's say apes, monkeys, orangutans, there are a lot of different types of monkeys, but this is just about evolution, so we'll talk about that later. Just in terms of behavior, a lot of the behaviors exhibited in chimpanzees, apes, orangutans, monkeys can be seen in humans. In terms of genetics, about 98% I want to say of our genes are found in monkeys as well. The 2% are what makes us human. What we tend to neglect as human beings is to realize that we are a diverse we are a diverse organism. Just in our stomach alone, we have about 10 to 15 trillion bacteria. That is a small fun fact that I'll put an asterisk around, and you can Google that later to make sure I'm not saying that incorrectly. But more or less, that 2% does mean a lot. So just because it sounds like it's not a lot, you say, oh, there's 2% of milk left over. But no, there's 2% out of the trillions and trillions and trillions of things going on in our body. But this is just the 2%. This is like the 2% milk that everybody enjoys. So let's go over the second question. Why don't we see evolution now? This is because of gradualism. More or less, gradualism is pretty straightforward, but I'll still go over it anyway. Gradualism basically says that it takes time for the right conditions to be in place for a new species to arrive, and even certain environmental pressures have to be held for this to happen. The best way to think about it is that Mother Nature is a chef, and she is trying to perfect a recipe using trial and error. A technique in which you try something, and if it works, yay, you don't have to test anymore. But if it doesn't, you have to try a different method to come to a different conclusion that either supports or denies your hypothesis. So we're going to come back to Mother Nature right now. While she's trying to perfect her recipe, she throws in 5 ingredients to see if they fit together correctly. She finds out that one of her ingredients has gone bad, so she has to sift through each one. And she tries a different item each time, removing one ingredient, trying the other 4, and could continuously do this. This can take hours, this can take days, because it is a long process to cook. If you've ever baked or cooked anything, you'll know. And let's say finally she finds out which ingredient it is, and in this case, it happens to be a shark fruit salad. And then she removes that shark fruit salad from the ingredients. And then she eats it and says, okay, this tastes good, but it has a bad aftertaste. So she has to continue this process of trial and error in order for her to come to the correct conclusion in which she has the perfect taste that she's looking for and also the no aftertaste. Now try to imagine this on a much grander scale. Mother Nature doesn't have 5 ingredients to work with. In the real world, she has millions. So imagine how long it just took me to explain that, and how long it will take someone to sift through millions of ingredients to find the perfect combination. This is why we don't see evolution on our scale, because we're trying to base it on our generations, which take centuries. Which is why scientists have been trying to use it on much smaller scales, which is why they've been using model organisms. Model organisms are organisms that we have studied very thoroughly, and we know almost 90%, I want to say, of their genes and how they work and in relation to other organisms. And for me, my favorite model organism is Acanor habitatus elegans, formerly known as C. elegans. They're easy to work with, and their generations normally range from, let's say, a week or so. So you can have a whole family going from the mother to father, no, mother to son to their grandchildren, and so on and so on. And this all happens in a week. Within that week, we are able to see accurately what they mean by different subspecies popping up. But since they're tiny, we can only kind of see the different morphological traits. Morphological just means what they look like. Some C. elegans can have big teeth, other C. elegans can have small teeth for different purposes depending on their environment. Like you would have bigger teeth for bigger plants, and harder things to get through. Smaller teeth are usually used for herbivores, and let's say with rabbits, they have molars, which allows them to grind plants, and which is usually grass, which we can get into another video if it's heavily requested. The last question I don't really want to answer because it is kind of silly. It says, if evolution is real, then why don't we see different mixed breeds? To a certain extent, we do see different mixed breeds. Like in the case of dogs, we can track the lineage of dogs, let's say even going from England, being artificially selected by humans, and there's a difference between natural selection and artificial selection. Natural selection happens naturally by nature, hence the term natural selection. Artificial selection is us. It's us influencing how something changes. This is basically a small scale of evolution in which we are choosing which traits we like the best, and we're putting them into different organisms. So, so to answer the question, we do see mixed breeds, and evolution is real, and it's kind of a weird question because evolution is a theory. It's not exactly like we're trying to say this is that and this is black and white. It's a theory, and the theories are used to explain how things work to the best of the ability. They aren't saying this is exactly how it is, but this is my interpretation of it. And there's a common misconception with people. When they hear theory, they hear, oh, it's just a shot in the dark. No. A lot of famous, more well-known theories go through massive, and I mean myriads and litanies of different scientific experiments just to check if they are actually credible. And if they are, then we'll check it even more and make sure if there's anything working against it. And this is called affirming the null hypothesis. This is seeing if there's anything else against evolution. And in this case, evolution, or against the theory placed before. So now, we get to one last misconception I just wanted to touch on. A lot of people fear that if we do follow the Darwinian survival of the fittest, the world is going to collapse. This is a false idea only because Darwin did mention in his book Survival of the Fittest, which basically means fit. It just means that you're able to adapt quick enough to your environment. You can have a lot of animals who are quicker than other animals, but let's say another animal is smarter than that other animal, and they would know not to do certain things. So even though you are faster, doesn't mean that you're more fit. So in the society today, we will relate that to what we already know. Let's say that we're applying for a high-paying job and it requires many certificates. Let's say it requires your PhD and a whole bunch of different certificates. Now, you have somebody who's very qualified, somebody who's very, very, very well qualified, versus somebody who just has their undergraduate bachelor's degree. In this case, the person who's very well qualified will be allowed to get into this position. If you don't want to see this as survival of the fittest, you can, but the person will have to the person who is less qualified, the person who only has their undergraduate bachelor's degree, will have to find another job. If not, they'll starve or become homeless. This is basically survival of the fittest at its most basic. It's not saying anything other than that. It's basically just saying that you are more fit for that environment, and if that environment were to change, then you will be able to adapt. Like, let's say if that job said, you know what, no more PhDs, we just need somebody with different certifications. But that person still has those certifications, so he's still able to get into the position, and the person with the undergraduate bachelor's cannot get in that position. Well, that's the end of this video, and I thank you for listening. Subscribe if you haven't already for more videos. I will be posting more, hopefully towards the end of the semester. Give this bad boy a thumbs up if you love science. If you love this video, please comment, rate, and subscribe. Tell me everything that was wrong with this video, how I can make it better. Also, I'm giving credit to all the sites which I stole all of this information from, which will be in the description when I upload this video. Thank you very much again for listening. Have a very nice night. Goodbye, YouTubers.